about 5 or 10% of species survived. So that was really huge.
When we look at mass extinctions, like what qualifies something as a mass extinction?
I think it's important to realize that species don't live forever. So actually, each species lives for maybe 1 million years, and that includes humans, Homo sapiens, T-Rex. But a mass extinction means that there's a whole lot of species going right at the same time. And the most famous one, of course, was when all the dinosaurs disappeared, or should I say the final dinosaurs. I mean, dinosaurs had been on the Earth for 150 million years, so they weren't all living side by side. But a mass extinction is where there's an unusually large number of species disappearing at the same time, and not just one group like dinosaurs, but across everything, So normally they're kind of ecologically broad, so marine creatures, creatures on land, plants, etc., etc.
Are we in one now?
Well, yes and no. I mean, I think people commonly say yes if we allow that a mass extinction could last over a few hundred years, a few thousand years. We need to scale what's happening at the present time back towards the past. But certainly some of the estimates would say we're pretty near it.
If we're in one, right? Like, I guess the question that would be then, like, okay, so if we're in one, it doesn't seem too bad.
Yeah, this is because each person is only aware of what's happening in their particular place. And many commentators like you and me, we're living in urban settings. And so the living creatures we see might be grass. And the tropics is where biodiversity is highest. And the rainforests in Brazil, in Indonesia, the coral reefs in tropical areas, they're buzzing with life. In one field of view, you're not just going to see 5 species. I look out my window, I can't really see anything. I can see an oak tree and a bit of grass and people and a dog. So that's 4 species. But if I was to move to a tropical reef or the Brazilian rainforest, I could maybe see 100 species in one view. And then you see the sort of creeping threat of reduction of those forests or of the coral reefs, and you think, yeah, something's happening here.
My idea was kind of to run through the 5 big ones that have happened, but I'm going to absolutely butcher the names of them that I looked up. So feel free to be like, that's not even close, buddy. The Ordovician?
Ordovician, not bad, not bad. So, yeah, do you want to go through the big 5 and I can...
Yeah.
So, the way we talk about mass extinctions, paleontologists, the people who study fossils, have recognized that there were these events, and they're not in dispute. People accept these. But it's important to note that there were many other events. So, the club, this top club of the big 5, could be joined arguably by another 4 or 5, according to different people. So the Ordovician was one that it was only observed in the oceans because there wasn't any life on land, really. There were big changes in the major beasts on the ocean floor, and it seems to be associated with a kind of freezing event. So this is over 400 million years ago. The next one was in the late Devonian, and there were definite extinctions that we would notice, like losses of armored fish. There were amazing fish in the earlier part of the Devonian, and they had heavy armor on the outside. There's nothing living really like them. And there were lots of changes of plants and so on land. And that seems to be, well, it was in 2 parts, but one of them seems to be associated with big volcanic eruptions. And then 250 million years ago was the really big one at the end of the Permian. And we identify it as really big because something like only about 5 or 10% of species survived. So that was really huge. All of the others, about 50% of species survived. But 5%, that's 1 in 20. And that's as near as, damn it, to, complete extinction of everything. And that was the end of lots and lots of marine creatures that had been around for a long time. The corals, the reefs disappeared. And on land, the forests disappeared. So it's not just that you're losing species, you're kind of losing a whole habitat, a whole system. And like on the Earth today, forests are really important as places for life. And in the oceans, of course, reefs are really important. So they went. And we can see the scale of it, excuse me, because it took 10 million years for them to rebuild. And then at the end of the Triassic, 200 million years ago, there was a further extinction event that affected life in the oceans and on land. And sometimes you mark an extinction event by opportunity. And at this point, the dinosaurs took off. So the other groups had been wiped out. The dinosaurs were already there. They'd been doing quite well, but they'd not really taken over. And they took over completely. And then finally, at the end of the Cretaceous, the famous one that everybody knows about, 66 million years ago, disappearance of the dinosaurs, also the pterosaurs, the flying reptiles, the marine reptiles, things like plesiosaurs, also ammonites. If anybody is a fossil collector, the ammonites are these coiled fossils that are very common in the Jurassic and Cretaceous. They went, and lots of other things. And it's also marked by opportunity, because the loss of the dinosaurs enabled the rise of the mammals, and the loss of various of these marine creatures enabled the rise of modern type sharks and various other things like that. And the main feature that marks them out is that life was disappearing in all habitats, in the oceans and on land.
Do we kind of ultimately bounce back in the sense that, I'll just put easy numbers, right? Like, okay, we had 100 species before, we had a mass extinction, we come back to having 100 species again? Or have we like fundamentally lost something each time one of these happens?
The life bounces back, and I think the way to think about it is, if you think of an ecosystem, which is like the food web of who eats who and all the different species that are living together in some sort of relationship, if you delete species at different points, normally something of the structure remains, and other species will evolve to do whatever it is. If you kill off the animal that specializes in eating a particular kind of plant, something else will take it over and keep the overall shape of the ecosystem. So we normally find that the before and after numbers are about the same. Life will recover.
Is there something that you would say that they all had in common?
The ones that go extinct, people look for this, because you would think that you might think of a mass extinction as a kind of clear out of a, like something in human history, that you have a massive catastrophe and all the old-fashioned stuff disappears and everything gets better. Normally it's not like that, because evolution is acting all the time. So species in the wild are acting on each other, and the competition for food or predator-prey relationships keep all the organisms, in a sense, on their toes. So they're evolving, they're responding to changing climates, blah, blah, blah. And the mass extinction usually is so sudden and unpredictable. It's not something that has ever been experienced before. So there's no opportunity for a kind of learning or adaptation, and it may be unexpected. So the comparison was, could it be that the weak organisms go and the strong creatures live? Actually, what seems to be happening is it's more like what David Raup, a great evolutionist, said was the field of bullets. And the analogy he gave was the First World War, where you have all these soldiers lined up in the trenches, and at the order, when the whistle is blown, they climb out of the trenches and run towards the enemy with their machine guns. Who gets killed? No way of knowing, because even if you're strong and physically fit and you've had a good diet and you're highly intelligent, you're just as likely to be mown down as the guy down the road who is poorly fed, smokes like a chimney, is completely hopeless, and it seems to be more like that. That it's unlike normal natural selection. It's the field of bullets. Everything is equally at risk.
You just get lucky, and
more or less, yes. And I think the features that make you lucky, I mean, there are a small number of things that are worth knowing. Number one, don't be too big. because big things need a load of food and they need a big area to forage, and small population size. Number two, be worldwide, live everywhere. Because if you only live in one part of the world, there's less chance that some population might survive somewhere or other. And I guess number three is have a fairly generalized diet. Don't be too fussy about your food.
I feel like we got those. I feel like we have those a little bit.
Humans tick a lot of the boxes, and there's lots of us, and so, but we're quite big in the normal run of things. Better to be cockroach-sized.
Like, I mean, is this a controversial field in the sense that, like, there's disagreement about it, or is this like, no, we got this buttoned up?
There's not disagreement about the events. I think people accept, the evidence is so clear and overwhelming. And what do I mean by the evidence? There are many places in the world where there are rock successions, piles of rocks that span across these intervals of time. And the best section is in China at a location called Meishan, which is an old quarry. And all the way up to a certain point, the rock is just stuffed full of fossils. And then at a certain level, the rock color turns much more black. And that's a general indication of the level of oxygen going down, because there's a lot of organic stuff being black, which is not being eaten. Because normally any organic matter on the ocean floor is eaten by something. There's all kinds of creatures moving around. And if suddenly a lot of that is being preserved, that means loss of oxygen and no fossils. So you can actually put your finger on the point, and above the level, almost nothing. And you only find maybe one or two species. These are the survivors. And that's how we talk about this sort of loss of 90% or 95%. It's based on actual counting in actual locations.
On kind of a personal level, like when you see those sections, right? Like what goes through your head when you see one of those?
It's amazing, to go to Meishan or to go to locations in North America where you can put your finger on the end of the dinosaurs. Here we are in this location in Montana, Kansas, or whatever. This is the point at which the dinosaurs disappear. And that's what gets young people excited about a lot of this kind of paleontology and geology. It's not all theory. You can actually see it and put your finger on it.
Like, what would the world at kind of those times be like? Because if I'm imagining a mass extinction, like I'm kind of imagining like a hellscape on Earth of, disaster movies. But would it be so unrecognizable to us?
Probably not. I mean, because a lot of the action is happening in the atmosphere. So I think for the end of the dinosaurs, yes, we would have seen a lot of really shocking stuff. So I'll tell you what it was like. You're standing somewhere in North America or Europe or whatever, somewhere within reach of this. The impact happened in the Caribbean, on the Yucatan Peninsula of Mexico. At that time, sea levels were much higher. And so this area was underwater. The meteorite hits, it was huge, it was many miles across, it penetrated deep into the Earth's crust, and then the equal and opposite reaction is an enormous volume, millions of tons of rock and dust come back up because they react to that huge impact. And the major pieces of rock would fall back all around the crater. The crater is something like, it's more than 100 miles across, 150 kilometers, something like that. So it is huge. And the crater is formed partly from the rock falling back as well as from that excavation process. But a large amount of the material going up is dust. And that goes high in the atmosphere and resides there. It doesn't fall back immediately because it is dust. And that encircles the Earth. Something like half an inch thick of dust was in the upper atmosphere, which was enough to cut out the light of the sun. And so on the ground, anywhere in the world, you would have felt that. You would have seen the lack of sun, and you would have felt the cold. And then more immediately close to it, almost as from Mexico as far as the US-Canadian border, within minutes of the impact, within hours of the impact, I should say, there would be a puttering of small glass beads. The beads are just about a millimeter in size, so very tiny. You could see them, but they're at the limit, and they might be a little bit hot. By this point, they've flown about 2,000 or 3,000 kilometers from the impact site. So they're probably quite cool. And what they are is melt products. So the two things that happen when the meteorite hits are, I say meteorite, asteroid, they're the same thing, really, a big piece of rock. Yeah. When the asteroid hits, it creates high pressure and high temperature. And so there's a great deal of melting. So large blocks are not melted, they fall back. Smaller stuff can be melted and flung into the sky, and it falls within that radius, into Brazil, up to the Canadian border, across just into Europe, but because the Atlantic was not as wide then as it is now. And these are melted from the impact site. And so they don't have the chemistry of volcanic lava. They have the chemical components of limestone, essentially, which is weird. At the same time, a heat wave would radiate out from the crater in all dimensions, and this would be partly caused by the energy of the impact, and that would burn up the forests and burn up anything in its way. I don't know how far it would have gone. It wouldn't progress all around the world, but it might have progressed a few hundred or even 1,000 miles away from the crater. So there's an awful lot of physical stuff going on, black sky, cold. If you're within reach of it, you'd be aware of the material falling back to Earth. But all around the world, even on the opposite side of the world, in what is now China, what is now Australia, whatever, you'd be very aware of something very, very horrible, nasty going on. And creatures would be dying everywhere. A lot of it isn't instant. The plants may die because of cold. They'll die eventually because of the lack of daylight, but that would take a little bit longer.
And in some of the other ones that weren't maybe just because of that direct kind of immediate cause, would it have been really different?
Yeah, I think all the other events wouldn't have seemed so immediately, dramatically, amazingly apocalyptic. All the other ones that I mentioned are caused, it seems, by earthbound processes, not by some extraterrestrial thing. And most of them are explained by volcanic eruption. And so this has become clear in the last 10 or 20 years that And they're called hyperthermals, meaning very high temperature, because that's the key feature. I should have stressed that with the impact, you actually get cooling. So it's important to bear in mind that the end of the dinosaurs is associated with lowering temperature because of the blacking out of the sun. But when it's a volcanic-caused event, it's warming mainly. And this is because of the gases. So, of course, we think of volcanoes. You don't want to get too close to an erupting volcano because you'll get swept away in the molten lava. Well, yeah, of course. And with a big volcanic eruption, that would have a big effect. But not worldwide. The worldwide effects come from the gases that come out of the volcano. And there are multiple kinds of gases come out of all volcanoes. Some of them, like sulfur dioxide, has a quick effect. It has a cooling effect. But when sulfur dioxide mixes with water and oxygen in the atmosphere, it produces sulfuric acid, which isn't good. And it has a bad effect, not only in killing the trees, but it leaches away nutrients from the soil. And so that part of forests that are maybe affected by acid rain can stay blasted and bleak for centuries because it takes a long time for the soil to redevelop and acquire the minerals that are needed by the plants and so on. But when you have a volcanic eruption on a global scale, well, let me reword that. When you have a huge volcanic eruption, that it can actually have effects over the whole of the Earth. And most of those effects are partly from the sulfur dioxide, but partly from the greenhouse gases. And there's a whole bunch of greenhouse gases that come out of volcanoes, particularly carbon dioxide, but also methane and water vapor. And all of these greenhouse gases have a warming effect. And although the sulfur dioxide has a cooling effect, it's fairly transient. That's quick. That's done. And the warming effects can last for much longer, not just a few days, they can last for months. So this is what is happening. The two things combined give you the killing effects of the hyperthermal, the heating, the warming is the key thing, coupled with acid rain. So this is what was happening at the end of the Permian and at the end of the Triassic and probably at the end of the Devonian, at least, those other big five. And the killing then on land, it's because the trees and other plants are killed by the acid rain. The warming has a huge effect because if you raise the temperature by 5 degrees, 10 degrees, life can't survive that. You know, we think that many plants and animals are happy at hot temperatures. Well, not really. Anything above 30 C is really not acceptable, 35. And so life will move. But then they get crowded because you're clearing out the very diverse tropics, which have much more life in them than any other part of the world. In the oceans, the main effect is from high temperature and acid. The acid will acidify the waters, and a lot of marine animals have shells that are made of calcium carbonate, so things like mollusks, shellfish, and even crabs and lobsters, their shell is made of calcium carbonate, and many others, and the acid will just eat away at that, and they can't really survive. So how long it would all take to kill, we don't know, but nonetheless, the killing effects of huge volcanic eruptions are deadly, and they've happened many times.
How come it hasn't happened for so long, though? Or at least another big one? I mean, it seemed like it was kind of close together, and now it's been...
Well, not really. I mean, if the first one was, between 3 and 400 million, 350 million years ago is the end Devonian, 250, 266. So they're spaced apart by 50 or 100 million years. So another one could come along anytime. People used to think there was a kind of regular pattern that we could say, oh yeah, there's one of these every 30 million years. We can kind of predict, the last one was whatever, 16 million, small one. The next one is going to be 9 million, 10 million years in the future. But I don't think there's a good evidence for a regular repeat.
Are you ready for some harder / listener submitted questions?
Indeed. Yeah, I am.
Are you more surprised by life's fragility or ability to endure?
That's a fantastic question. And I don't know how to answer it, really. I think you can answer it both ways somehow. I think you can say, well, life is amazingly resilient, that, many of the plants and animals we see around on Earth today have been on Earth for a very long time, hundreds, thousands of millions of years, and yet it just takes something like one of these volcanic eruptions on the scale I was mentioning to have that devastating an effect. And of course, we can see the impacts of human activity, showing how fragile nature can be. So, yeah, I can't really give a single straight answer to that, but it's a great question.
Domino or all at once? And I think what they mean by that is it usually kind of, okay, it affects this thing, and then that thing follows through, and then it creates all this, or is it like get everybody all at once?
I think the hyperthermals, the majority of mass extinctions, were domino, because I think that certain species would go quickly, the ones that were most affected in the part of the world that is most affected, which is a little what we see today, that around the equator, think of Africa, the Sahara Desert, because of global warming, the Sahara Desert is getting bigger, and therefore species that live in and around the desert are going to be hit first. And then I think consequences would flow out. And I think that's the same with most of the past extinctions. The only difference being the end Cretaceous, the impact, that was much more instantaneous. I think that was like all done within a week. It's not like all done within an hour, because the reverberations, the movement of dust and so on takes days, maybe a week.
Oh, it was that fast?
The dust in the upper atmosphere, that might have stuck around for months and kept the Earth black. But I think the worst of it would be over in a week.
Would we have survived any of them?
We might have done in certain parts of the world, but whether we're allowed our technology or not, if we had none of our technology, probably not.
Organism you miss the most, organism you miss the least. And I think what they mean by that in the sense is like, oh, we lost this, and this thing was really cool, versus, oh, we lost that, and that was probably really good for us.
That's a difficult one to answer because I think everybody would have a different opinion. I love dinosaurs, so I'm very sorry we lost the dinosaurs. But then I don't want them back. We've seen the Jurassic Park movies, and you think, why do they persist? Come on, this is the most stupid thing in the world. And having T-Rex wandering around would not be good, I don't think. What would one regard as a species we can do with that? That's a terrible thing to have to even try to answer. I think most people would respond and say every species has equal value, even though we may not much like the mosquito or the rattlesnake. Nonetheless, we would say they have a beauty, they have something about them. And many would say, let's wipe out all the rattlesnakes, it'll make people happy. But it's not for us to judge.
Do species ever go extinct just because they're dumb? And I think...
I suppose you could point to... There's something that we see we've seen in historical time, that when people first went to certain islands that had never had human beings on them before, a lot of the species, the animals, were naive. Not exactly dumb, but they were naive in the sense they didn't run away. They were just curious, and we've all read about or seen stories of, I don't know, penguins. You go to Antarctica, the penguins are curious, they'll come up and have a look, even though you might shoot them. And in the early days, probably people did shoot them. And I hope nowadays people would not, but nonetheless. And I suppose the story of the dodo, people arrive on the island, they see this dumb-looking bird wandering about, it couldn't fly, it didn't need to. And it didn't need to run away because there were no predators until humans arrived. And then we go around hitting them on the head with sticks and shooting them. And you could say they're dumb. But they're just dumb because of our bad behavior. And presumably without us, they were doing just fine.
What animal of today, animal or organism today, do you think is going to be the best survivor?
I think I would just give the usual answer, which would be the cockroach. And the argument there is they can kind of live anywhere. They're all over the world. They've adapted to humans very well. That's why we see them so much. They're quite small. They're huge, millions and millions of them. And I think they're kind of difficult to kill. If you've had cockroaches in your house, you can't stomp on them. They're quite thin and they seem to survive. You've got to make a special effort to kill them. So they would do well. Rats and mice, I think, would do very well because they kind of live everywhere. And all of those beasts, they're willing to eat anything. They'll eat plants, they'll eat other animals, they'll eat decaying stuff, they'll eat paper. They seem to survive on almost anything.
Last one, kind of the big one, I guess. Do you think that we survive?
I think that most people are optimistic and would say that we will find a way. And it's easy to be loud and shouty about these topics, but it's better to reflect. And I think we can survive because we can, I hope, optimistically, that decision makers will accept that there are certain changes to human behavior that would be good for the Earth and would slow down some of the changes that are happening. But of course, the other argument would be we have a certain amount of ingenuity, we have technology. So if Armageddon faces us, and we rather hope it does not, that we can somehow find a better way to live in harmony with the wonders of the Earth. But even if Armageddon hits us, we have technology. I'd be a little more cautious about that because, of course, it's easy for people who are not in the field to think, oh yes, those science guys will invent something, and you've got to take a slightly more nuanced view and say, well, what is it you want them to invent, and is it really possible to do that? But yeah, there's ingenuity. But of course, I guess the thing is, how many people would be preserved? Would it just be the people with the money to buy the technology? I just don't know. But I suppose you can answer it both ways, and both of them are positive in their own way and would give you a little bit of hope.
I don't know if I have faith, but I do have hope.
Yes.
I guess that's the way that I would look at it.
We have to hope that humans are decent and that they will work together in a good way.
What are you studying now? What's kind of the focus of your research now?
I'm focusing very much on the end Permian mass extinction, but I'm very interested in the recovery of life. So how does life get back? And there's a lot of very good tools we have now for kind of modeling ecosystems and understanding how all that process of recovery happens and how the new groups fit into the system and kind of build a whole new world. So yeah, that's what we're looking at the moment.
When we get into that recovery, is it kind of nature goes wild in the sense that like some crazy organisms pop up, or do we kind of go back to the basics?
It's a bit of both. And there are certainly some crazy things going on. And we sometimes call these disaster species because they are the things that take advantage of tough conditions. And they may do well in times of perturbed environments, but eventually things do settle, and it may be a different cohort of species that come along and create that longer lasting ecosystem. And a good analogy is we can see it in nature today. If they're building a road, for example, you rip up everything and cut through the landscape, and then you can see the way life comes back on the margins of the road. And the first things to come back, there are certain kinds of herbs, plants that just grow very quickly. And you might get one species. In Europe, it's rose bay willow herb, which is a kind of purple flower, and it just covers the bare soil very quickly. And it does fine for a year or so. And then bushes and small plants like that come back, and they gradually get better established. And eventually you get trees. So this is something that ecologists look at a lot, succession. And it may take 100 years for the disturbed landscape to recover. So that's a sort of concept within human lifetimes, within ecology. And I think it's something similar on the world scale, that you get this sort of opportunistic species that come in quickly. They're fine. They do well for a little while, but then they get supplanted and replaced, and you get the gradual build-up of the ecosystem, usually kind of starting at the bottom with various plants and bushes and eventually trees, and species, animals come back in a similar sort of way when they get the opportunity.
That's pretty much all the questions that we have. What's kind of coming up next for you? I know you have a relatively new book out that covers a lot of these things.
I do. I was going to wave a copy, but I don't have a copy to hand. But it is called Extinction, How Life Finds a Way. So it's a bit about both sides, the sort of negativity, but also the positivity of how life can recover. And, looking from the present viewpoint, the most obvious example was the end of the dinosaurs gave the opportunity for mammals. We are mammals, so we'd better celebrate that extinction event. Otherwise, we might not be here quite in the way we are. And looking back at older events, they triggered recoveries of life that built parts of the modern types of ecosystems we see today. So there's always been that bounce back, which is nice if we take a broad philosophical view. But taking a narrower view, survival of Homo sapiens, as we were discussing a moment or two ago, you can't be so sure about that. Of course, life will come back, but whether humans are part of that is up to us, really.